Hello, we are going to create a new circuit in Tinkercad. When you're in Tinkercad at tinkercad.com and you click on the icon in the left corner, it takes you to your dashboard with all of your projects. Usually starts you off with 3D designs. We are in circuits and we're going to create a new circuit. Starts us off with nothing in our work pane. Almost everything we need will be here in the basic components. If it's not there, click on this menu bar and click on all, and everything will be available and you can find it. We're going to start by adding a small breadboard, and our breadboard has some power strips on it. One is marked with a positive, where usually we're going to place the positive power, and that's the voltage, positive power coming out of that. And then the one that is black and is marked with the negative sign is the ground, where we will place the black lead that leads to the ground on our power source. And then we will take jumper cables and move the power into the center of the breadboard and make connections like such. We are going to light an LED light. So let me grab an LED and I'm placing it on the breadboard across two rows, row 6 and row 7. And these rows are not connected underneath the breadboard. And so I have not connected to the two ends of the LED. Rather, the left negative lead, the shorter leg on the LED, is connected to the negative end of my power source or the ground. And the positive leg on my LED light is the longer leg, and it is connected to row 7. If I place a cable from row 7 to the positive power strip, I'm going to make it red just to show that that's where my positive power will come from. I can then apply some power to this LED and I will get it to burn out is what would happen, because 9 volts trying to push through a circuit with only an LED to run is going to produce way too much current for this LED light and will blow it out. It will literally burn up the LED light and cause a smell, and it's not something we want to do. But in Tinkercad, we can do it by pressing Start Simulation and recognize that that's just way too much power for this circuit as it is built. When I stop the simulation, the LED light will go back to being a well-behaved LED that is not blown out. If you do that in real life, you want to throw that LED away. So I grabbed a resistor, and now I'm using the rotate tool over here. If you hover over it, it'll remind you that that's pretty much the only tool you have here in Tinkercad circuits. And I'm rotating that resistor just so that I can get one end of the resistor into row 7 with that LED, and the other end of the resistor into any other row except for row 7. And right now I still have this circuit going through the LED, and the power would definitely want to just do that. So I need to break that circuit, grab that red jumper cable, select it, click on the end of the jumper cable that I want to move, and then I will be able to drag it around. And I want to drag it so that it's in the same row as the right terminal of my resistor, which is row 11. Any of the endpoints on row 11 would work fine for making a connection with that resistor. So now, oh, I made these the wrong color. So silly. All right, so now when the positive power comes out of the positive end of my battery and pushes through this wire here, through the resistor, through the LED, through the cable, into the ground, back into the battery to do the repeat in that circuit, I should be able to light that LED, and with the resistor in there, the flow of the of power will be reduced, and I will not blow out my LED. I am going to change the value of the resistor to 220 ohms because that is the lowest value resistor that we have available in real life. And it says this is way too much current going through that LED. It's not enough to blow it out, but it is enough to make your LED not function as well or as long as you would like. You're stressing out your LED. We're going to be running our powering our circuits using an Arduino as the power source. So I'm going to use, there's two ground sources on our Arduino and they are equivalent, so it doesn't matter which one I grab and bring over to provide a ground to my power strip. Make it black. And then 5 volts, we'll go ahead and do 5 volts. We could do 3 volts. I just want my LED to be nice and bright, so I'll give it a little more power. And when I start the simulation, I see that indeed I have enough power to light the LED, and I'm not getting any kind of error telling me that have too much power for that component to be functioning properly. The last thing we're going to do for this circuit is add a switch. We could add a slide switch. I'm going to add the push button switch because it's a little easier to use. And so it is just the right size for placing across this trough. And when I place it here, each of these 4 terminals on the push button are in different rows on the breadboard. So none of those 4 terminals are connected to one another or to any other components. I'm going to break this circuit again by moving this jumper cable out of row 11, which connects it to that resistor, and move it over here to row 20, which is also connected to the bottom right leg of the push button. Additionally, I'm going to take another jumper cable and go from any of these holes that are in row 11, which is the same row where the terminal on the resistor is. So I'll be connecting those 2 components by putting a jumper cable here and then going to the same row of the left leg on my push button, completing a circuit. Now when I start the simulation, my light lights only when I push it. And so now what we want to do is reproduce this exact same configuration with these same components on our breadboard. Then we'll plug it into our Arduino and plug our Arduino into a USB power supply. And it should function the same way, where when we push the button, the light will light up. So we have our completed circuit in Tinkercad, of which I have a screenshot right here, and we're going to reproduce it on our breadboard. I have all of the components here, some jumper cables, an LED light, a 220 ohm resistor, which in these kits they have 5-band resistors, so those are going to be red, red, black, black, brown, bronze, or whatever. But these guys, the colors are a little off, and so just grab the ones out of the 220 ohm pack, and don't worry if you have a resistor that is higher than that. And we got our momentum switch, our little push button switch right there. So we're going to put these parts onto the breadboard. I'm going to add my ground cable. I'm actually going to put it in the pink row. I'm going to ignore the colors on there. I know that the power bars are just electrical, are just metallic strips underneath there. And so I'm going to go ahead and build this just like it is on the diagram in Tinkercad, with the bottom row being the positive power red and the top row being the ground black negative power. And then I'm going to bring that power up to the breadboard into a row, which on my diagram is row 6. I'm going to go ahead and put that in the first spot of row 6. I could put it anywhere in row 6 as long as row 6 is where I'm going to put the short leg of my LED. So the LED has a long leg and a short leg, and the short leg is negative, and so I'm going to place that on the breadboard where the negative short leg is in row 6 and the longer leg is in row 7. I bend that back a little bit so you can see it. And then my resistor goes in next on this diagram. You know, there's hundreds of ways to build this same circuit, an LED with a resistor and a push button switch, and hundreds of ways to do it on this solderless breadboard. And this is just the way that I have it done in Tinkercad that I'm going to reproduce here. And that resistor doesn't want to stay in there, but now I got it in there pretty good. That's where some tweezers will come in handy, but I don't have them. Okay, and then a little jumper cable going over to where I'm going to put that push button switch. I'm actually going to put the push button switch in first because it is the more difficult component to position. And so I'm going to put it across that trough, that big area across the middle of the breadboard where there are no connections. And then my jumper cable is going to connect the leg here, this left lead of my push button switch, which is in row 16. It's in row 18 in my diagram. And then in row 12 is where I ended up putting that other end of the resistor. So in that same row, I'm going to put the jumper cable. The jumper cable is going from row 11 to row 18 on our diagram. As long as that jumper cable is in the same row as the resistor and the other end is in the same row as the button, then we are moving our circuit along. The last thing we're going to do is go from this last row of the button and make a connection in any of those ones there. So I'm going to move on because that one is not wanting to go. And then back to the positive power. And so that looks pretty much like my circuit. I just have that push button switch moved over a little bit more. I was concerned I was going to run out of room. And so now these guys right here, I'm going to connect to my Arduino with the red positive power going to 5 volts, just like in my circuit online in Tinkercad, and the black negative ground going into either of the two grounds on my Arduino. And then I'm going to plug in my Arduino, giving it some power and my circuit some power, and I hope that when I push that button that little light's going to light up, and there we go.